Okay, this in the last video, I just tried to make a video. I tried to make a video where I tried to have you understand a little bit on. So I didn't have all the answers. Certainly not when it came to regulation. Kind of how a battery works and how you can have kilowatt hours and kilowatts and discharge depths and efficiencies and computer implied capacity factor and what the construction cost per kW is versus what it is per stored kWh, and how you're really going to compare this to other things. Now the reason I'm doing this is we're going forward and we're going to make an analysis of a island grid and see if the battery really helps us or hurts us, and how do we optimize the battery. And then we had some different kinds of revenues, demand response and other things, and we had some O&M costs and efficiencies, and we were able to get this is reasonably close. We had some degradation in our batteries, and do we earn our how do we earn our revenues from regulation that I really couldn't quite figure out, and how do we earn our revenues from demand charges, and should that be a amount per megawatt hour, which in some of these cases, like in this California case, it was you were earning, if you switched it to a megawatt hour, you were earning 934 per hour of the actual storage you dispatch. Perhaps that's reasonable because you only had a implied capacity factor of less than 1%. So maybe for 1% of the hours in California, you got this kind of number. Now in this video, I'm just going to show you some mechanics of how I did it. There's going to be a little bit of repetition, but I'm sorry about that. And here's how we do it. So these are some of the files I made before, and I had even done this with you. Okay, but I want to go through it slowly. So what you need to do is you need to have this file called read PDF to Excel open, and I have made a lot of changes in this file just really because of this. Okay, and if you just a minute, so let's go and read some stuff. Okay, now the first thing we could do is we could read this in. Let's read this in. Okay, that's our kind of by region. And if you read that in, this is a fairly simple case. And when you read it in, you need to have, it doesn't work with that new Windows thing. It's Adobe Acrobat. I'm not favoring Adobe Acrobat or anything else. And notice we have a couple of NAs here, and we have some brackets. Now if you press Shift Control A, I put a couple of new things to fix the titles. I'm going to talk about that in a minute. Now, if you go to Adjustments and Conversions, I want to convert NA to 0. I want to do that. And I don't want to remove the parentheses. Okay, is that all right? And so that then you press continue, and for this one then you notice this parse spaces, Shift Control U. But for now, just use the regular one. Okay, and it's went a little bit slowly. I think the only reason I can tell that it went slowly is that I have this thing open. Now, one of the things I did is I said, okay, remember when you press Shift Control A, down here it says Shift Control U to parse the spaces. Okay, and you press Shift Control U, and that's a really helpful little kind of thing. It just it's like the text to columns thing, but you put it in a macro or a function, and it helps a lot more. And you notice the NAs became zeros, and it left the value sources and all that. And I suppose you could even do it here. Shift Control U, and that fixes it. So that's one of the kind of little changes in the thing. Then the next thing you could do is you could go, and I'm going to do something dangerous. I hadn't done this before. For PJM, we might want just these things here. We can just get these ones. I just want it for PJM. So you'd go to the paste it. Okay, and this time you could do it in two different ways. It's got these funny little things in the front. I'm not going to worry about that. You could press Shift Control A and just reset the column number. Okay, now it didn't work because of those kilowatt hour things at the bottom. I'm not going to redo the. You just read the. If you have multiple columns. Oh no, it didn't. Well, okay. Enough of that. I'm not going to waste time with that. Then let's go and get the New York one. Sorry about that. Don't let the perfect be the enemy of the good. That's all I can say. Okay, ISO. Oh no, and this is all nervous because I feel like, oh my God, it's not perfect. I'm gonna get a dislike. Okay, and then we put this in. Okay, and then we press Shift Control A. That's a kind of standard normal distribution. That's a standard normal one. The only thing to talk about here is you notice it put memo on a separate line. If you would have pressed Shift Control A and go to adjustments and conversions, and I think you press this combined rows. I shouldn't say that like I don't know this. And then you press the same thing. Okay, then if it's got a blank row, it tries to put them together. Okay, because sometimes that's important when you're reading it, and sometimes it's not. So I'm going to leave it like this, and then what we're going to do is just copy this. Okay, and the next thing I did is, okay, well, you know, they did a little bit of a different kind of format, which is fine. Here and in New York, there were some incentive payments. Okay, and I just put the O&M costs below I just reformatted this a little bit. Okay, and then we Control minus to delete, and then we just copy all of this. Now I'm gonna insert Shift Control Control space bar and Shift Control plus or whatever you want to do this. I noticed that nobody kind of does it like me, but what the heck. And then we're gonna put this into our, and I'm gonna delete some of the sheets. Alt-E-L. Okay. That was embarrassing, the last thing I did. Okay, and this is our New York one, okay? So we're just going to put this in the right place. I still haven't changed the name, and I say, okay, let's put it right here. Oops. Let's put it right here. Okay, and then we put the years in a different place. And then, okay, I said, all right, well, we did this for all the others. This is the advantage. Let me name it NYISO. And it's kind of the advantage of replicating it then. We'll take the last one we did, this one for Texas. And make sure you start on line 56. How's that? We need to start on the same line, and I'm just going to copy this. Now, if I didn't use the indirect, the whole thing wouldn't really work. I hope I had to start right on line 56. Okay. Suppose I could, Okay, and then let's make D a little wider, blah, blah, blah. And this one, now that instead of, because I used the indirect function, I said take assumptions, row number 10 and column number 8. But in our New York thing, and I think I showed you how to copy this last time, so I'm not going to do that again. This was in column number E. So we just put E, and that's kind of how that indirect thing works. And then, let's see, are the cycles per year really 215 for New York? Yes, they are. So this is a real kind of demonstration on using a couple of the tools. All right, and then we, okay. And then we just have to fill in some of the numbers. Now in New York, they told us the cost, this is the one I was having trouble with, 462 and 51. But they said it's net of the incentive payment, so it's a little more confusing, but I'm going to go ahead and put 462 and 51 in. That's because New York gives you an incentive payment. Did I leave 51? And they give you here how the incentive payment kind of works, okay? And then we go down, and perhaps that's not the real interesting thing, and then we get our cost per kW of capacity, or the amount you can actually discharge per hour versus the cost of per kWh of storage, different metrics for getting this. All right, and then we put the warranty cost in the model. Now I had to kind of go and find this, so the warranty cost in the model was up here, and we get the implied cost here from the warranty analysis versus the construction cost in the model, and this time it gave us our famous 20% again. Oh, good. And so our construction cost in the model, you know, perhaps I should have done this. This is our, let's do our cost per kW discharge. Okay, and this is USD per kW. So I've got it just the capacity up here. So this was shift control 1. So we have about 2,000 US per kW. Double the cost of a solar panel, by the way. Double the cost of a solar panel to get a little bitty capacity factor of 2.45. And you can start to see the issues, okay? Then they had the demand response payment and the regulation payment. So we go up and we see, well, the regulation payment was 8.79, and the demand response payment was 300. Oh my gosh, 300 per kW a year, which seems high because that's a lot higher than the cost of a peaking plant. So you have to ask, why would you pay 300? And this one, look, I tried to take a brain pill today, but it didn't work. 8.79. Okay. And then we have the kind of the O&M cost, and I hope I have the efficiency somewhere up here. And these shift alternate C, this comes because I colored the sheet. And well, no, it comes, then if you color the sheet, it's going to go to the red sheet, of course, and take what's in the red analysis. And that was one of the hardest things to do. And it doesn't work absolutely perfectly. So maybe Excel won't put it in the next version. I hope they don't copy it. Okay. Now, so once you have all of the kind of parameters in, and then the charging cost, this was another big issue. This time the charging cost was only 24. I don't know why the charging cost was so dramatically different in different scenarios. Okay, that sounds reasonable as an off-peak kind of cost. And then I escalated these, and then we did the same thing. Now the O&M cost in the model is a minus, and we can kind of see if we're getting a similar operating cost, O&M. Okay, Shift Control R, and I got a very close. I'm very close on the O&M. We're not close on the delivered energy. Just let me pause for 1 minute. Okay, I had a. You take the charging cost in the model, and I had to take this from the charging cost, and I had when I copied it in, I didn't get the right numbers. And then we take the we get an implied megawatts of this, and take an efficiency, and I'm kind of different on this one when we're the same on the others. Well, I'm going to keep going. And finally, we get our typical kind of reconciliation. Now, the regulation revenues were, they didn't have any. So even though they had a price for the regulation, they didn't get any revenues for the regulation. Did I get that right? And then they had big numbers for the demand response, and was I right? They had a regulation payment, but no regulation revenue. So I'm not. These are just questions to ask. I don't know what's going on. I'm not claiming I have everything right. And then our demand charge revenues. If we take the kind of two categories up here, we can see how many revenues we were getting, and then we have the capacity in terms of the amount we can discharge, you know, the max discharge, and then we get kind of the implied capacity payment, which was it was reasonably similar, not very similar, but reasonably similar, and then we can take those same. Take the total energy that was discharged. Now, this was a tiny little bit different than, not a tiny, maybe big, but then we get an implied payment for kind of a spike in capacity payments of more than 1,000. Let me just look at the one other issue, and then I'm going to stop this video. Okay, just to finish it off, I'm in the New York ISO, so I had to take this from column D, and I think I had column E. Now when I put it back to column D, then we're kind of okay. Here's the number of cycles per year. We have less than 1% capacity factor. We multiply the cycles per year times the storage hours, and assume 100% discharge, and then when we do that, we get a very similar number here. This is similar, and again, there's some degradation over time, same kind of degradation, and the demand charge revenues are really, really high. Whether you can really earn those is a different question, and that's what we're going to do now, is going to kind of put this in our nice little island scenario. I'm going to press Shift Control C here, and understand what does the cost of the batteries really have to be to make it really economic when we look at some actual load curves. Okay, and so that was just a more mechanical one, and now I'm going to show you how I put the database of costs and other parameters for the batteries together. Okay, fini.